Hello. Okay, this is our group video presentation of Advanced Artificial Intelligence CS591. We are teammates of three. That's me, Sozul, Divya, and Asuk. And I will start this presentation by describing the paper, Computer Machinery and Intelligence. Uh, and like I would like to describe it by the Alan Turing, as many of us have heard about him. He is known for cracking the Enigma machine in World War II. Um, Also, we may also have heard about the Turing test. This paper describes about Turing test and what it means when a computer passes it. Okay, and this paper starts with the question: Can machine think? Um, he finds the question unhelpful, and the process of defining machines and think can be dangerous. So he replaced the question with the imitation game, also known as the Turing test. So talking about the imitation game or Turing test, it is played with three people: a man, a woman B, and an interrogator C, who may be of either sex. The interrogator stays in a separate room apart from the two. The objective of the game in interrogator is to determine which of the other two is the man and which is the woman. Okay, then he knows them by the labels X and Y, and at the end of the interrogation he says either X is A and Y is B, or X is B and Y is A, and thus your A's objective in the game is to try and cause C to make the wrong identification. The objective of the game for the third player, that is B, is to help the interrogator. uh, she asks the questions like, will X please tell me the length of his or her hair? Like both of them can give similar remarks as, I am the woman, don't listen to him, and such condition may rise. And like A can also ask similar question like, what will happen when a machine takes a part of A in this game, and in such scenario will the interrogator decide wrongly? So this lead us to the question that, can machine think? Okay, and finally, since the Turing first started the questions with can machine think, then he started a question that also lead to the similar question. Now, so this leads to an argument against machine thoughts, and so such can leads a question that, if A as a computer can convince the interrogator that they are humans, then this means that functionally it resembles that the computer is thinking. And he also counter examples to claim and provides them that they are convincing. Mm, And likewise, when people think about computer cannot bring consciousness, often bring art and music are active that only human can produce. Turing was clear about the physical and intellectual capabilities of human by the separation of the room and the use of written communication as well. Okay, so he then noted the concept of digital computer and conclude the word machine as a digital computer in today's world, we can resemble quite to it. Um, and he noted that the idea of digital computer was an old one, referencing the various analytical engines developed by Charles Babbage until his death in 1871. He defined the digital computer as having a storage of information for calculation and protocol that follow, as well as an executive unit for operation purpose, and a control that ensures that the instructions are performed in accordance with the rules and in correct order. Like the numbers which can be assigned to part of the storage with instruction like add 34957 to 70764. Likewise, normally instruction are carried out in the order they are stored. Creation of the rules their computer must follow is described as programming. And likewise, he also in the second part of the paper he develops some contrary views like theological objection, like thinking function of a man's souls that machines cannot do, like such as like the head in the sand objection. For this, his response was that the power of thinking more highly than other base belief in the superiority of man on this power. Likewise, for mathematical objection, his argument was there are a number of results that shows there are limitations to machine, and the best known is the Gödel's theorem, 1931, and similar kind of mathematical uh, limitation are not only limited to machines but are also uh, but also do apply to human. His response was linked to it. Similarly, there were arguments of consciousness, disabilities, and the most important one was Lady Lovelace objection, where she stated that the analytical engine, which was developed by Charles Babbage, couldn't originate any human behavior. And for this, Turing responded that despite the machine at that time couldn't was not able to show that property, but it is not impossible to create equipment in the future that will think for itself. Similarly, the other contrary views were for the nervous system, behavior, and perception, and finally learning machine. Learning machines are resemble to thinking machine, which will provide by the waiting the end of century and then playing the imitation game. The problem here is only mainly linked about the programming and not about storage. Regulating in the order in rules of logical system are important in each step. Also, a random element can be useful for searching the solution of a problem. Okay, like now I have completed my part, and I like to say to Divya to continue her presentation.
Yes, my research paper is about machine learning in Python, main developments and technology trends in data science, machine learning, and artificial intelligence. Um, this paper is explains about smarter applications and also like comparison with artificial intelligence and machine learning. This paper is discussing about smarter applications that are making better use of uh, data uh, from large business, and it is also includes Python, which is the most popular language for scientific computing, data science, and machine language. It also covers the usage of low level libraries as well as high level APIs. Here, the Python continues to be the most preferred language for scientific computing, data science, and machine learning. Um, okay. Can you skip to the other part? Okay. This slide is about scientific computing and machine learning in Python. We can see in the diagram, we can see the standard Python ecosystem for machine learning, data system, and scientific computing. The sharing of the data between the CPU memory and other parts of the machine learning program, data preparation, model training, and visualization. Yeah, this slide is about classical. classical machine learning. Here, the deep learning is a machine learning subcategory that focus on the. Oh, sorry, guys. Here, the deep learning is a huge data that consists of unstructured data sets like text and images. Because of its simple and consistent APIs we use on small medium data sets. Can you skip to the other part? In assemble learning, this part is about assemble learning. Assemble approach which combine various machine learning algorithms or models that are frequently utilized for providing stability and improving model performance and reducing the bias variance trade-off. Interpretability, in this slide we can see the classical machine learning on GPUs, which is the graphical processor interface. We use matrix multiplication in the computer. It includes the matrix to matrix and matrix to vector multiplication. We use C and C++ languages for this interpretability. In this slide, we can see deep learning APIs. Deep learning APIs are one of the best APIs in the hardware. Is I think Ashok, you can continue from here.
Yeah. Thank you, Divya and Sajul. My name is Ashok. Uh, Today I'm explaining the paper about the survey benchmarking principles on machine learning devices, which includes the hardware devices like GPUs, FPGAs, and ASICs, and one more thing like deep learning software frameworks too. So there are majorly two parts, like 11 metric and the 6 metric. Can you skip to the next part? Yeah. This is the structure for the AI machine. Uh, there are majorly two parts. One is front end and another one is back end. The front end, which covers the frameworks like PyTorch, Keras, which is comes under the 6 metric, and the back end, which are the hardware devices like GPUs, FPGAs, and the ASICs, which comes under the 11 metric on hardware. So these are the a benchmark organization, and we can say as a 7 benchmarking principles. Next, and this is all about deep learning on hardware devices. Uh, as we know just now, like AI hardware and the GPUs, FBAs, and the ASICs, which are under this hardware learning. So we can see in the next slide. So the GPU devices, it is a processor which can process all the inputs and outputs to the other parts of the AI device. And next, the FPGA devices. This comes under a chip management. Um, when you go to vector components like RAM, ROM, everything which is very logged inside the one chip and which is processed by the FPGA kit and tested by the FPGA programmers. This is all about FPGA devices and the ASIC devices. These gadgets have high all through the power and low energy utilization on the grounds that can be created by using chips, and these are interlinked to the GPUs in the AI machine. Next. Yeah, here we go. We are talking about the benchmarking hardware for machine learning, right? There are some of the attributes: ASICs, FPGAs, and GPUs comparison. If you talk about computing performance, there are high, low, moderate, and if you talk about low latency, energy efficiency, capability, research cost, research risk, upgradability, scalability, chip price, UBCOM, and time to market. There are some highs and lows and moderates too. Can you skip to next? That's all. We are done with presentation. Thank you.